Imagine a world where human hands never touch some of the most ambitious structures in space. Instead, robots do the heavy lifting, meticulously assembling giant telescopes, power plants, and orbiting research laboratories. Strange as it may sound, this future may be closer than we think. Right now, scientists and engineers are looking at revolutionary ways to build infrastructure in orbit, not by sending it fully assembled from Earth, but by building it module by module directly in space. And one of the most promising tools on the horizon is a new breed of spacefaring robots. When we look at the Hubble Space Telescope or the James Webb Space Telescope, they seem like triumphs of human engineering. And they are. Hubble was carefully packed inside the Space Shuttle Discovery and launched into low Earth orbit, while James Webb was folded to fit inside the nose cone of an Ariane 5 rocket, before unfolding its complex mirrors and sun shield to its final position at the Sun-Earth L2 point. These telescopes have opened up the cosmos, giving us breathtaking views of galaxies, stars, and nebulae, millions and even billions of light-years away. But there's a big drawback to the way we build these telescopes. They're limited by the size of the rockets that carry them. As we continue to push the boundaries of what we want to observe, the tools we need are getting bigger, more complex, and simply impossible to launch in one piece. For example, scientists are now thinking about building telescopes with mirrors far larger than anything we've ever put into space. Bigger mirrors mean sharper, deeper views of the universe, allowing us to peer further into the dark corners of space and time. But it's becoming increasingly clear that if we want telescopes with mirrors over 25 meters wide, for example, we need to rethink our approach. Instead of squeezing these massive instruments into rockets, we may need to build them directly in space. That's where autonomous robotics comes in. The International Space Station, ISS, has given us a model for building large structures in space. The ISS wasn't launched as a single unit. It was built piece by piece over the years, with several space agencies from around the world contributing modules and components. And while the assembly of the ISS was an impressive feat, it still relied heavily on astronauts and remotely operated robotic arms, such as the Canadarm and the European robotic arm. While incredibly useful, these robotic arms are limited. They're controlled by astronauts and can't perform complex assembly tasks autonomously. What scientists are now looking at is something much more advanced. A robot that doesn't just assist in space construction, but leads it. Recent research published in the journal Acta Astronautica sets out a bold new plan for building large telescopes and other infrastructure in orbit using autonomous walking robots. Manu Nair, a researcher at the Lincoln Center for Autonomous Systems in the UK, led the study and presented a concept that could reshape the way we build in space. The team has been working on a design for a walking manipulator that could autonomously assemble huge space structures, such as telescopes with 25-meter primary mirrors, or even solar-powered satellites. The proposed robot, called the End-over-End Walking Robot, or E-Walker, is unlike anything we currently use in space. The E-Walker has 7 degrees of freedom, allowing it to move and assemble parts with remarkable dexterity. This is crucial because assembling something as complex as a space telescope requires precise handling of parts weighing hundreds of kilograms, even in the microgravity of space. The E-Walker concept goes beyond what we've seen on the ISS, where robotic arms perform limited tasks under close human supervision. This new generation of walking robots would operate with a much higher degree of autonomy, adapting to new tasks and environments as required. But why would we need such a robot? Imagine trying to send a telescope with a 25-meter mirror into space. This type of telescope, which researchers call LAST, Large Aperture Space Telescope, would be too big to fit into any existing rocket. Instead, it would have to be launched in pieces and then assembled in orbit. LAST's primary mirror would be made up of modular segments that could be seamlessly connected in space. Each segment would have its own interfaces for data transfer, power, and thermal management, allowing the E-Walker to assemble it piece by piece. In the researchers' plan, the E-Walker wouldn't be working alone. There would also be 2 other spacecraft, the base spacecraft BSC, and the storage spacecraft, SSC. The BSC would act as a command center, giving instructions to the E-Walker, monitoring its status and coordinating its movements. Meanwhile, the SSC would store the mirror segments and other components needed to assemble LAST. This setup would allow the E-Walker to retrieve each part from storage, position it correctly, and secure it in place, all without the need for human intervention. The potential for autonomous assembly robots in space is immense. If the E-Walker prototype proves successful, it could pave the way for new types of space telescopes, orbital research stations, and even solar power plants that could beam clean energy back to Earth. The researchers conducted a feasibility case study of the last mission and developed 11 different concepts of operations, ConOps, for different scenarios, including multiple E-Walkers working together to share tasks, reduce the load on each robot, and streamline the assembly process. Some of these scenarios even involve cooperative robots that can adapt to unforeseen challenges in real time, giving us a glimpse of how future robotic missions might handle complex tasks. Researchers envision a future in which advanced robotics, automation, and autonomous systems, RAAS, are central to space exploration. These systems would be highly adaptable with backup systems, modular designs, and the autonomy needed to cope with the harsh environment of space. While robots are already being used in unique ways here on Earth, such as the Boston Dynamics Spot robot navigating hazardous industrial environments, the leap to autonomous construction in space will require new levels of technological sophistication. One of the most exciting aspects of this research is the potential to extend our capabilities far beyond what we can currently imagine. The ability to assemble complex structures in orbit opens up possibilities that were previously out of reach. Not only could we build larger telescopes, but we could also create entirely new types of space habitats, manufacturing facilities, recycling stations, and even orbital warehouses for the storage and distribution of equipment. Of course, there are many challenges ahead. The researchers point out that their work is based on theoretical models and simulations, and the E-Walker concept will need extensive testing before it's ready for real missions. However, the groundwork being laid now could transform the way we explore and operate in space. In a future where telescopes are too big, stations too complex, and space colonies too ambitious to be launched in one piece from Earth, robots like the E-Walker could be our greatest allies? Ultimately, the move towards autonomous robotic construction in space reflects our growing ambitions as a species. We're moving away from simply sending astronauts to the Moon or Mars. We're now talking about creating a sustainable space infrastructure that could support a permanent human presence in orbit and beyond. This vision requires a new approach to building and maintaining space infrastructure, and autonomous robots could play a central role in making it happen. As we look to the future of space exploration, one thing is clear: the capabilities of robotics and artificial intelligence will be critical to our success. We're on the brink of an era where the obstacles of distance, gravity, and isolation in space could be overcome by advanced, self-sufficient robots working to make our boldest visions a reality. With every step we take towards autonomous orbital construction, we're setting the stage for a future literally built among the stars.